What's up, everybody? Welcome back. Today we're working on our Rube Goldberg machine. And today's topic is trying to get some sort of like cohesion between different areas of the simulation. So, here's like what we've been working on. Each of these like views that we're seeing right now, we're calling them chambers, are defined by like an individual WASM module. And the idea is that like people can code whatever chamber they want with whatever kind of custom behavior they want, and they'll just upload the module to our website, and we can like basically pick which ones that we want to be part of like a global simulation, right? So here's like you see some examples here. There's like some balls falling through some pegs and some platforms moving, and we're kind of imagining that maybe they're all going to be like stitched together, kind of like in some sort of like virtual cylinder, right? And we want to be able to support like all sorts of custom behavior. So like maybe one of them is like, you've got like a portal system and like, the ball goes in one portal and gets fired at the other. Maybe you have one where you have like a heavy mass and the ball orbits around the mass and gets like shot out into the next chamber. Maybe you have one that's like kind of like Mario versus Donkey Kong and the balls are like rolling down these things. And you have like an AI that's like trying to walk up and jump over the balls. Also whatever people imagine, we want to like support that. And so we have these chambers, we have them running, and now we want to like stitch them together. So I think the plan of action is like first we're gonna have to take the chambers that we have and put them in some sort of orientation. We might need to duplicate them a little bit because we might not have enough to really see like large scale effects. But we're gonna have to like give each chamber a position in some sort of like global world space. We're gonna have to like take the balls that are running through the simulations right now. Right now we have like just 5 balls per chamber. We're gonna have to like take those out and put them somewhere else, and then somehow figure out how to like feed them into the correct chambers, and like how to like ask the physics of that chamber to be applied to these balls, etc. And then we also are gonna have to handle like if a ball is in between 2 chambers, we're gonna have to make sure that the physics from both chambers are run on that ball. And yeah, I think let's just kind of start there and see what happens. So we are 2 minutes 20 seconds in, and let's just start looking at how do we like assign chamber locations. So everything is written in Zig, or I guess all of our server-side code is written in Zig. The WebAssembly modules can be written in whatever language people feel like. We've exported like a physics library that can be used in C, and then that combined to whatever language people feel like using. So been working with that. Okay, so we have a simulation Zig. This guy right now, he contains the number of balls. And this simulation is like, I guess right now kind of wraps a single chamber. And I'm just trying to decide if that's how I think it should be. Because right now we have this kind of like wrapper class that says like, hey, I'm going to have many simulations here, and I'm going to run all of those simulations in lockstep. So basically, like once per step, once per like period of time, we say, hey, I'm gonna call each of these guys one by one. And so, kind of logically, it might make sense for us to pull the balls out here. I guess the name simulation really indicates that this is supposed to own all of the chambers. So we could do something like this where maybe we have like our balls here, and right now we have like an interface that we can interact with the chamber from. The idea is that like that interface could be implemented either in like client-side JavaScript or in like server-side WASM bindings. And I guess we could just kind of like make this like take many chambers, and then we could keep like chamber IDs like this or something. Maybe we don't even need chamber IDs, but maybe we need like chamber positions that would take in like a, pause 2 or something. No. These would just be like integer positions. So yeah, anyways, maybe we just like, we start by making the chamber interfaces say we can run any number of chambers in the simulation. I think that makes sense. So then we need a way to like lay out these chambers somehow. So what's that going to look like? We're going to have like, let's just start with a 2x2 grid. I think that will make everything simpler. because we have like 4 chambers to test with right now, so we can just kind of do this. And we'll say that if you go off the right, you come back in the left. I would think that you could visualize this as like a bunch of chambers wrapped around a cylinder, right? And you could kind of imagine that like horizontally they go around like this, but you could also imagine that like you could go into the cylinder and wrap around this way too. So like you have like vertical wrapping and horizontal wrapping. I know it doesn't like really make sense, but we don't have to adhere strictly to real world physics. And so we can say that if you come down this side, you come back out this side, and vice versa. You come up here, you come up here. Okay, so then the question is how do we want to represent their position in the world? So I guess we could specify that we have like 0 here. we could just store its xy. Maybe we don't even need to store xy, because if every row of the simulation has the same number of chambers, we could just store by index. In which case, all we have to do is store maybe like the width of this thing. Now, if I say chamber width, that's confusing because that could mean this. So what is like a good word for this? I don't really know. No, chambers per row, I guess. And we'll just start this at 2. And then we actually don't have to do anything. We could just say that like these guys, you can derive their position based off of this and their index in here. Yeah. Okay. So let's rename this to chambers. Renaming it will make sure that like not only did the type change that'll cause compile errors, but everybody that uses the word chamber mod will be like fucking broken, and that will force us to make sure that we've like evaluated the type change at that position. Okay, so here we initialize the chamber with the number of balls. I guess here we're going to loop through and we're going to say for chamber we have chamber, and for each chamber we're going to try to initialize it. Seems reasonable to me. Seems reasonable. And here we assign chambers like this, and I'm just gonna like ditch. Okay, so we at some point implemented this thing where basically at every physics step we write down the position of every single ball and we save the state of every single chamber, so that we can reload it later if we see like some sort of physics bug. This is like this is like difficult to deal with all the fucking time. It just like causes also every time we implement anything, this thing like becomes like a problem. And also we haven't really used it at all. So I think I'm just gonna comment it out for now. And if I feel like coming back to it later, I'll come back to it later. Okay. So just fuck that. Fuck this. Okay, so for each step, we do all of this stuff to the balls, and then we do this stuff to the chamber, where we say like, hey, could you apply whatever you want to do? And then we apply collision between all of the balls again after. Or not again, sorry. Just after that we say like, did balls run into each other? Let's like make sure that they push each other away and stuff. So I guess this just becomes 4 self chambers. We're gonna have to like figure out which balls are in which chamber, which we don't really have the concept of right now. But let's just for now maybe just chamber step all at once. I guess maybe we'll just immediately break. So we'll only step the first chamber, and we're gonna have to come back here and we'll say tie balls back to chambers. I think that's reasonable. Okay. Does that build? Surely not. So we have simulation WASM zig. This is at 68. Can we disable this as well for now? Just so we can like kind of figure out what our API should look like. Let's not build the like client side simulation. So we'll just kind of comment this out. And comment this out. And we'll just not think about that for a second. Just for a little bit. We'll come back to it. Okay, so app.zig 174. Okay, so he initializes each simulation individually. And so I guess here we used to keep a bunch of simulations. Now we can just keep one simulation because that one simulation is going to hold all of the chambers. So this kind of goes like this. And that breaks all sorts of stuff, I'm sure. 68. Right, so here we're just going to say var simulation is equal to simulation init with our allocator. I guess, how does this work? So right now the chamber, this is init empty. So init empty creates an app where the simulation vector is like has nothing in it, and that doesn't really work for us anymore. That doesn't work for us because the simulation now has to be initialized with the chambers it's working with. Okay. Because before we used to, I guess, support like dynamically inserting simulations. You would have like an upload, you put the simulation in, and then it just gets added to the list. Now we are not doing that. That's going to be like a more complex action, I guess. Maybe not. This guy still owns externally the tying of each chamber to the database and back and stuff. That's fine. Okay, so we'll just kind of like ditch this init from history, like we were saying before. This history stuff is just complicating things, so we can just ignore it for now. So we'll kind of just everywhere where we have init from history, we just kind of like delete that path of code. There we go. Much better. Much better. I don't think it builds still, probably. No, it doesn't. So we need to take that like vector of simulations here, and we'll just kind of like ditch this init empty concept as well, I guess. So comment this out as well. Kind of take all of this stuff and slap it up here. Yup. This goes away. Okay, so we have our loader. We need our capacity. Where does that capacity come from? Oh, we were passing it in here. So this is anywhere that said capacity, we just replace with chambers len. There we go. Okay. Then this can go away. Now this stuff, we are going to get all of our chamber mods. Once we have created all of our chambers, we can then pull interfaces out and construct our simulations. So I guess we say this is equal to simulation init alloc seed. So where did we get the seed from before? We did this. And now we need to put all of the like interfaces in. So this is kind of odd because this guy doesn't like own the interfaces, which means that if we were to do, let me think. Do we even want to like inject all these things right now at the beginning? I guess that's fine. I think later it's going to make sense for us to like kind of lazily inject chambers in because we're going to want to be able to adjust the simulation while it's running. But for now, it's probably simpler to just do everything statically up front and then deal with that later. I think that's easier for now. Okay, so the problem is though, these guys are, this is taking like a slice of chambers, and so that means that this has to be like an allocated pointer. So I guess here we're storing like the concrete implementations, and I guess we could also just store the like interfaces as well. Or we could say to the simulation, hey, you own these things. Now I was gonna say that we could take in here the like chambers themselves and like pull the interface out, but we can't even do that because this file needs to be compilable from WASM as well, because we like do a client-side simulation, and in that scenario we can't like take a concrete type here. That was the whole point of this interface. So I guess here I guess we'll just store it externally. I think that's the simplest thing to do for now, is that I don't know if this is like the most reasonable thing to do. I don't know if I really like this, but we're going to do it this way for now anyways. So we're going to say that we have like chamber interfaces, and we'll just kind of like say that this is a chamber. And I'm probably going to come back and change this because I don't like this. But it gets us moving. So I'll say fix me. This doesn't feel right. Yeah, so we're just going to loop over each of these things, which we were doing down here before. And we'll basically say for each of these, we're going to... What happens in a pen chamber? Okay, this stuff goes away. We're not appending to a simulation anymore. And I guess we just say what? There's a lot to worry about here. I think we're just going to disable all of the dynamic stuff about appending chambers as well, just temporarily, because it, again, just makes problems to think about. And I'd rather not. So somewhere in here we call pen chamber, and just like fuck this noise. So we'll just kind of say fuck off. Okay, that's good enough for now. Then we can just, for now, say we won't append to the simulation. And just while we're here, in this case, we say this is equal to pop this thing, and then we add one more thing. Which is the chamber interfaces. We pass in the self chamber mods get last chamber. Okay. So now we should have iterated over all of our chambers. We have everything in the state it needs to be in. Oh, fuck. We can't call this. Fuck. I guess we will say here. This kind of comes up here. Var red is equal to this. He's got his allocator. And simulation is just going to start as undefined. Chamber ifs is equal to chamber ifs. Yup. Which means that we need a chamber ifs here. Like this. Okay. And then once we've done all of this, we can just look at chamber ifs items. Boom. Boom. Now this is a little sketchy. Because to store array list, since simulation holds slice, and realix would be disastrous. So like the way that these like array lists work, right, is you have like chunk of memory at like 1, 2, 3, 4, right? And you like push items in, you push items in, and then you try to push in a 5 and it goes like, uh-oh, it doesn't fit. I'll make a new buffer that's twice as big. And so he makes like a new one that goes like, approximately, I think they usually do like 2x the size or something. But this now will have a new address, right? 5, 6, 7, 8. And then they copy all the elements over, then stick your 5 in there, and you have like more space, blah, blah, blah. So if I like pass this to another class and then push something in, it can like reallocate the vector, and that's like really bad. So that's why I'm just saying like we shouldn't be doing this. We should like maybe store these things, like we should fix them or copy them out or something. But we are shortcutting because we just want to get something working. Okay. Doesn't compile yet because 175. Yeah, it should be self simulation deinit instead of deinit simulations. There's only one now. 175. This again. This goes away. We don't need this anymore. And what else is broken out? So 199. Init simulation. This also is unused now. 150. Yeah, this is also unused. There we go. Are we good now? History does not exist anymore, right? Because we were annoyed that we had to deal with it. We might bring it back later, we might not. And unused function parameter, alloc. Okay. Surprising. But I guess it is how it is. Okay. Okay. We do not quite build yet, so because we didn't actually store the simulation here, so we have to say ret simulation is equal to this. Okay. There's more broken now. So here, when we run, we used to run over all simulations. Now we just run over our single simulation. So we just do this, self-simulation, self-simulation. And this is just like this, I guess. Sure. Yeah, that seems reasonable. Seems reasonable. No field simulations at server zig 207. Right, so everything here before used to fetch from the server, like a client would fetch from the server for each simulation. I guess we only have one simulation now. So everywhere before where we were doing like /0 / do something, all of this is just hard coded now. So here, all of this stuff comes into non-indexed target options. I don't really want to do it this way. For now, let's just assert that the number is 0 and fix it later. Or we'll just say you know, anything that's not 0 is no good. Let's do that. So we already have this function get simulation that does like the bounds check it for us. So we can just kind of say here, we're just going to extract app simulation, and if ID is not equal to 0, we return out of bounds. Cool. Probably, I think somewhere else we call num simulation somewhere to see how many there are. So we should just always return 1 in that scenario. That's here. So we are just going to return 1. So we just go 1 like this. And this is going to be 1 character long. Okay. No field chamber mod at 228. Right, so on save, this is just going to be so we here, what is this for? We are trying to get the simulation state for a single simulation. So this is going to have to change APIs before. Before we were saying like, hey, for each simulation, I have 1 chamber and I want to load the state for it. Now this is going to have to be like, here are the save states for every single one so that you can load and present it. Oh, that's annoying. That's annoying. So I guess the concept of IDs is still important. It's just that the IDs map to chambers now instead of simulations. So we're gonna undo this this change we did for the ID parsing, and we'll just say that it's now, instead of num simulations, it's num chambers. And we are still going to have like state associated with it. It's going to be chamber state instead of simulation state. Save. Here this is saying give me, oh, this is saying like write a history file. We'll just kind of ditch that for now because I don't want to deal with it. Reset also is going to be for the whole simulation now, but get chamber is definitely still there. So reset is going to come down here for like the whole shebang. I guess this doesn't come out anywhere. It's just this doesn't have an ID with him anymore. So I don't know, man. Fix me. Fix me. Reset. Sim. Get chamber ID, still good, and then the rest of these still good. Okay, so wherever we did like the ID parsing, these URLs used to come in as like 0 simulation state, right? 0 chamber WASM. So basically some of these guys just have to come out. So reset is now like kind of like a global concept. And save just doesn't exist anymore. Fuck that noise. So we're just gonna comment this out because it's again related to history and I don't want to deal with that yet, so that goes away. Reset now just comes to the global stuff. And so if we have reset, we say reset with no ID, which means that our reset thing needs to not have an ID associated with him, so this becomes void. And this was not simulation state anymore, we're calling this chamber state. I think that makes more sense. And I guess really, like, I guess we should probably save, like, all of the chamber state should come up at once. Right? Like, going chamber by chamber doesn't really make sense. We have, like, one simulation. We want the chamber state for everything. So maybe chamber state also actually comes out of, like, the index target options, but the WebAssembly module fetching itself stays indexed. And that's the only thing that's indexed. Which I think is fair. I think that's fair. So, okay. And I guess then this gets renamed to simulation state again. Because we want, in the simulation state, we're going to want the balls as well as all of the chambers. So all the chamber save states. So I think that actually makes plenty of sense. So this is going to actually come back to simulation state. And we're going to have to say that on simulation state, we have this purpose, which is to get the simulation state. Yep. Which means that when we try to get the simulation state over here, wherever the fuck that was, here, we are going to look at our simulation, and this chamber state is going to be chamber states plural, and it's going to be a double array. Yeah. That's starting to make sense. It's starting to make sense. So here we have const simulation is equal to server app simulation, like this. We're going to have our balls is still this. That's great. Chamber states is where we're going to get a little complex. So we're going to say chamber states is a access variable is a array list of constituents. I'm actually gonna split out a type for this. I guess we can do it inline, fuck it. Because it just makes like freeing these things easier. So we're gonna say const chamber save list is a struct. And he's got you know, an array list like this. But we're gonna have like a pub function dinit. Actually, we'll just make a function, I guess, that frees them all. I don't know. We'll see. Fuck it. We'll just do it in a different block. Chamber states is equal to stood array list init alloc. Okay. Self server alloc. Would you recommend studying physics or abusing Unity physics system is good enough for hobby? I don't have a very good feel for that because I've never really made a game or anything. For what I'm doing, we're doing it by hand because it's fun to learn, but I don't think that our physics engine is really good by any way, shape, or form. It's kind of shit. I think it really depends on what you're trying to accomplish. Really depends. I think that most people who write games are going to use the built-in physics engine from their game engine, and that's fine if that's what they want to, like, if that's what you're trying to do. It really depends on what your goals are, right? If your goals are to understand physics systems, then probably, you know, writing your own is a better use, like, will get you further. But if all you're trying to do is use a physics system, then, like, fucking go ahead, use a physics system. All I do AABB when I try to do by myself. I don't know what that means. I guess you're talking about bounding boxes, probably. Which seems reasonable. Like, I don't know. I don't know. I can't really answer this for you, I don't think. Okay, for each chamber state, we are going to free it. So I guess we're gonna call this chamber saves. So here we're gonna free each chamber save, then DNet our whole array. Okay, cool. That's good enough. Then, we are going to lock the mutex for the simulation and iterate over every chamber. Okay, that seems reasonable. And then we're going to just basically try to append. And this isn't error defer, this is just straight defer. Straight defer. Got a question about your next setup. Are you using Flakes or Home Manager? No to both. Flakes are not, like, they're considered experimental. I don't know what that means, but I don't really want to get in, like, I don't really care about Nix that much. Like, so I don't really want to, like, get into the nitty gritty experimental features. I'll wait till they show up as, like, a real, like, you know, unexperimental thing. Home Manager, I mean, I'm happy with just, like, I have my dot files in a Git repo, and that feels like good enough for me. So I haven't really like looked out for anything better for like 10 years. But maybe that's a little extreme. 5 years probably is when I started doing that. Okay, what is next here? So we're trying to say that we get some simulation for this chamber. So this just turns into chamber save this. And then we just push that thing back. So error defer. If the push fails, then this needs to get freed. So self server alloc free chamber save. Yep. And then we chamber saves append this save. All right, we're getting somewhere. Then here, this is chamber saves and chamber states, I guess we called it. This breaks out of this block, but that's fine because the memory is still good here. And then we stringify here, so the memory is still good as well, and then we're chilling. Okay. Flakes have been experimental forever. At this point, it just means that they refuse to stabilize the API. Yeah, I mean, like, I don't want to like learn a thing and then have it changed up from under my asshole, right? Like, just like I just don't care. Like, yeah, I just don't care. Num chambers is not a valid thing. What do we need like num simulations? Or we need num we need to be able to like say how many of these WASM modules should we pull. So here we say this is gonna be num chambers. And num chambers maps to num chambers like this. Okay, no field name num chambers, so we need to, wherever the fuck we define these, num chambers here as well. Switch must have all possibilities, and we're missing save, so I'll just kind of comment that one out because we're not dealing with it right now. No field name simulations at 207. Okay, where's this? Right, so when we get the number of chambers, this comes from simulation, simulation, is it not chambers here? Okay, then non-void return type at 203. This is probably from this commented out return. So can we just comment out like, or I guess simulation reset should be pretty straightforward. We can just do this. So this is going to come from self server app simulation reset. Boom. I guess const simulation is equal to this so that we can lock the mutex. It makes sense as well. Okay. All right. Okay, we compile. Surely everything is still fucked, but at least we compile. Let's see what happens if we run this. I think that it's gonna be broken as shit. Yeah, super fucking broken. So I guess we start fixing the client side now. On the client side, they're calling num simulations. This is now going to be num chambers. Num chambers response like this. I don't know what we're going to do with this, but we'll figure it out as we go. So now we kind of construct this like remote simulation, one per thing. I guess we are going to still have one chamber render, one canvas per chamber for now makes sense maybe, or maybe we want one global canvas for everything. I think the path of least resistance is to still keep it so that we have one canvas per chamber. So creating one instance of like a canvas makes sense there. We have this like simulation renderer thing. So I guess this needs to turn into like a chamber renderer. And this chamber renderer will render some balls and a chamber. So I think actually there's nothing has to change here. We'll just keep calling it simulation renderer so I don't have to like fuck everything up. Okay, so we make a canvas for this simulation, but the simulation is a chamber. And then the only thing that has to change here is when we get the simulation state, we are probably going to want to feed this in somewhere globally. We have one simulation with one set of balls. And I guess we are going to have to tie each ball back to each chamber for now. But for now, maybe we'll just put all of the balls in the first chamber. For now. Just so that we can like see something. Maybe we just don't look at the balls at all. Yeah, okay, so I think the very least resistance here is we call simulation state here, which now has chamber states as one of its things. So we pass in the balls as well as this chamber. This chamber is what? The chamber. This chamber is like the WASM module? I think it is, yeah. Yeah, so we'll make one canvas per chamber. Okay. And this is gonna feed in, this is feeding in the path to a WASM module. And so this is actually still fine as well. Still fine as well. Sorry, I missed on the stream. Not sure if this helps out. Maybe it's worth checking out later. Something that merges memory between two or syncs memory between two clients. Interesting. So I think that we just like manually copy paste between some right now. And I don't think that there's anywhere where we really need like sync memory, but it does seem. I'll take a look. Maybe I'll take a look. Maybe, but we'll see. I think maybe I don't need it, but it's good to know that it exists. So this is making one remote simulation object passing in this chamber object. I see. Okay, sure. So right now this has like an index of the chamber. And so for now, we can maybe just write down that index. So this, we're not going to be fetching the simulation state with a prefix. We're going to be fetching the whole simulation state. And we will store the ID. Okay. Which means that when we load the chamber, we should be able to load the chamber with this simulation state dot chamber states I. This dot I. D. This dot ID. And this is going to take in the simulation state. Okay, that might work. Might work. Okay. So now I see nothing, which is kind of odd. Network. When we call num chambers, call user info. Okay. What is num chambers returning? Num chambers returned 0. That's not good. That's not what I expected at all. Is the DB not populated? Let's see. So main, we are initializing with these chambers, and can we just say we have this many chambers. typo. Oh, god damn it. God damn it. Fucking JavaScript. So we have 4 chambers. That's good. So you guys are saying that I just fucking suck ass here. This feels fine. Oh, num chambers response, num chambers. Feels okay. Oh, it did return 0. It did like straight up return 0. So why the fuck is that happening? That was in server Zig. We have num chambers. Gets parsed out to num chambers. That's fine. And here we are pulling server app simulation chambers line. So where the fuck is this? Like, what the fuck? Chambers, this many. Like, surely this is just a bug that we don't save something where we're supposed to. We have 4 chambers. Chamber 0, yeah, it's bugged. It's bugged. So here we pass in chamber ifs items. Chamber ifs gets pushed in here. Append chamber here. We are supposed to append chamber ifs. So what the fuck is the problem? Oh. God damn it. God damn it. Oh, that's also fucked up, actually. Fix me. These error defers are not right at all. These are incorrect. Because the ret actually needs, like, they copy, like, their internal state out into the application struct here. And so when we, like, start, like, pushing things into it, it doesn't necessarily know that we did that. That's fucking annoying. But it's okay. We'll deal. We will fix it later, as always. Okay, there. Now we have 4 chambers. Refresh here. Console errors at simulation state.chamber state is undefined, which makes sense. So here we have chamber state. So this is gonna be chamber state here. And we pass this in manually here, so this kind of goes like this. And really, we should be getting into the habit of not rebuilding every time because we don't have to. Here we can just refresh. Okay, here we go. We're back. We're back, baby. So obviously there's some problems here, right? The fact that the balls are getting rendered according to this first chamber and all these, they kind of look fucked up, but that's a good sign. We're on the right path. Okay, so I guess this was kind of more like move 1 simulation many chambers. Now this is like totally fucked up, but it's kind of correct now. And like it's like the objects live in the right place. Now we need to like assign balls to chamber IDs so that we know where to place them. Aren't the FPS too low? I'm not worried about that at all right now. That's probably just because for each chamber we're refetching state for all chambers. I'm not worried about it at all. we'll come back to that. Okay, so we need to know which chamber to render the balls into, and by extension, which chambers to render, like to step with. So let's think about this. What is the simplest thing to do here? We could store within the ball, like chamber ID, but I don't think I want to do that. I think it makes more sense to say here, ball chambers. So this is going to be numballs as well. And we'll just store which chamber each ball lives in. And for now, we will just hard code this as 0. So here we can say like numballs are 1 U8 0 times numballs, I think is how you do this. So you just like duplicate this array numballs times. Okay, that's fucking broken because this is a U8, not U size. That's fine. I get it. I get it. Okay, and then when we fetch here, when we fetch the simulation state, we're gonna have to give like ball chambers as the same thing. And this just becomes ball chambers equals simulation ball chambers. Boom. Okay, so that's all good as well. And we can look at our index now. And basically what we want to do is we want to make sure that wherever we're rendering the balls, we only render the balls for this chamber. So here, we're going to want to do something like iterate simulation state ball chambers. I don't know JavaScript very well. So I think we look at length here. Int I is equal to 0, or let I is equal to 0. I is less than this plus I. I'm sure there's some sort of like fancy array list composition I can do, but fuck that noise. We'll call this balls for chamber. This is going to be an empty array. And then we'll just say if simulation state ball chambers I is equal to this ID, and surely this is going to get fucked up in some way, so we'll triple equals it. Balls for chamber push the ball at position I. Then here we can give balls for chamber, and then everything else should just work. So what we expect to see here is that we should just see the balls only rendered in the first chamber because all balls are hard coded for the first chamber. And instead we see fucking shit. So what the fuck is going on? Refresh. Console simulation state ball is undefined. Oh my god, fuck off. It's balls. Which I think we should just be able to get away with like a quick refresh. Okay, good. So now we're only seeing balls in the first chamber. Big win for us. Big win. And now what we have to do is basically like when they get pushed off the edge, we have to put them in the correct chamber. So what we should be able to do is, and we should only run physics for the correct chamber. So we can look at our simulations egg and apply wrap. Right now we were just kind of like basically putting the ball's X and Y positions to be between 0 and 1. We want to do this same thing, but just make sure that we adjust the chamber ID as well here. So we can say like, we're gonna do this. Self.apply wrap. This is gonna take in we're gonna do this kind of like all at once, I guess. And I guess we're actually also gonna do this. We might have to do this twice. Because like we're gonna like move the balls, run the physics in the appropriate physics chambers, but then that might push the ball back out. So it might make sense to do like apply wrap again over here. That seems possible. Fix me maybe unnecessary. But maybe not. And this is going to take in self as a simulation. And he's just going to say for ball self balls, we're going to do something. And we're going to keep track of the index as well. And here we're just going to say if, first let's assert that we're between 0 and 2. We should never be making it so far that we're moving through 2 chambers in 1 frame. That would be insane. But we should just double check that. So we'll say assert that the ball pause x is greater than or equal to negative 1.0, and that it's less than or equal to 2.0. Yeah. Yeah. And we'll do the same for y. Okay. Now, if ball pos y is greater than 1.0, we're just going to say that the chamber ID is plus equals to num balls. And then if it is less than 0, we subtract that. And then we could do something similar for x. And this is just going to be 1 instead of numballs. Now, after all of this, we could be in like a totally fucked position. Like they could be negative, they could be positive. And so instead of validating first, we'll just kind of change these to be I64s. And then we will make sure that the I64s are within like 0 to number of chambers. So like I'm assuming that like a mod b keeps like sign here, right? So if we kind of need to do like while self ball chambers I is less than 0, self ball chambers I plus equals ball chambers len, then we can do self ball chambers I percent equals self ball chambers len. There we go. There we go. Physics cap question mark? I don't know what that means. Okay. So I think that might do what we want. Might not, but it might. So here he doesn't like that I used usize here when I switched to I64. And then certainly like somewhere where I'm indexing with these things, it's gonna be like fucking mad. Actually, I guess it makes sense for this to stay as a usize. And then when we do this math, we'll just copy paste it out. So we'll say ball chamber is an I64 is equal to self ball chambers I, and we'll just int cast this raw. It's not like we're gonna have like fucking like however many you would need to overflow that number. Then we'll do ball chamber here, just kind of like boom. Num balls here. That's fine. That's also fine. This also needs to turn into ball chamber, and then at the end here we just say self ball chambers I is equal to ball chamber, and we can int cast this, and it should be safe to do it like this because it should be guaranteed at this point that it is above 0, which is all we need. It still doesn't compile. Fuck my life. Floats, sign integers and floats must be used rem or mod. What's the difference here? Caller guarantees denominator greater than 0. Otherwise, the operation will result in a remainder division by 0. So -3, -5 mod 3 is 1. Oh wait, that's exactly what I want, huh? Maybe not. I'm not sure. So we'll just leave it as is. And here we'll just, I mean, it's fine. It's just fine. Because we have already inserted that everything is above 1 or above 0, so I don't actually have to think about this. Maybe we could get this out somehow, but fuck it. Cannot assign to constant. So here we need to iterate these by pointer so that we can assign to them. And then here we need to ampersand this so that we can iterate by pointer again. All right. let's see if this looks at all sane. Wait, maybe? So the grid should be one. This should be here. This should be here. We can actually fix this by allowing two to be next to each other. Let's see if we can fix this. So right now we have like kind of like divs. Can we like put this whole thing in like a flex box? Like, can we do like how do you do like div? I guess we want like body. And we want to put the body like layout. How do you do flex box? Flex box. Hello. Where is like layout? Is just layout flex maybe? No. Display? Display. Thank you. Okay. Cool. And then we want to set like the number of elements. So flexbox nom elms. And then this is actually fucked up because I can't do it on the whole body because it also gets this shit. So we actually need all of these chambers need to end up inside a container, which is doable. That's easy to fix. So we can do somewhere we just write body here, and here we'll just say that all of these guys should go in document get element by ID chambers, right? Then we put this here, and then we make a index HTML change that says we have a div here, ID chambers. And then we can start playing with the styling for here. We can say that we have chambers and display flex. Okay, and then flex box max width. Everyone's mad at me because I didn't fix my closing tags. Look, guys, browsers will put up with anything. How do I say like limit number of items per row in a flex box? Guys, I know. I'm a fucking idiot. I know. What? Oh no, this is not. Isn't there just like a fucking number you can type somewhere? Oh, I want CSS grid, huh? That is what I just want grid. And then grid. Get grid. Okay, fuck. Limit number of items per row in CSS grid. Grid template columns. Sure. Grid template columns 2. No? I've heard that using higher quality phrasing questions leads to higher result. You know what? Fine. You know, I mean, here I can just CSS grid. Fuck it. Like, using the LM here is fucking stupid, anyways. Display grid rows columns. Grid column start and grid column end. Place a grid item at column line 1 and let it end on column line 3. That's not what I want. I just want like, tell me how to lay it out. So here they just put CSS grid num calls. Like, come on, man. Grid template columns. Yeah. I mean, that's what I thought. Grid column. Okay. I want like grid template columns. Really felt like what I wanted, huh? Okay, so if I say like 1 here, 2. Okay, so that's obviously not it. So they have 1, 2. Oh, I see. Oh, so they want like 1, 1, 1. What is 1 for real? I've never seen this before. I swear I've worked these before, and I've never seen 1 for real. What the fuck is that? But this is what I want, so I'll just copy 1 for real for now, and then come back and understand it later. Like a fucking dumbass. There we go. Okay. So the question is, does it look like... Oh! Did you see that one fucking go over the boundary? Now, there's a problem here where the physics is still being applied to the wrong chamber, so we can fix that. But it does look like the balls are actually like moving between chambers almost correctly. Almost. And I guess we should copy paste this 1 for real over here to like style. Like this. That way we won't lose it. Okay, so let's go into our simulation. And over here, wherever we run our physics, which we must do somewhere, here we are going to... So this guy expects like a array of balls. Why did the balls change color? Oh, that's pretty funny. Because they just are like kind of alternating red and blue based off their ball ID. And their ball ID is like changing index based off of how many there are in the frame at a given time. We can fix that. I'll fix that in a minute. But first I want to basically collect which balls are associated with this chamber. So here we kind of want to say that we keep track of our chamber ID. And we're going to do something like, I guess we'll make like an array list again, which is like kind of wasteful, but it's fine. I don't give a shit. So we'll say var chamber balls is a std array list of ball. Oh, this is kind of odd. Okay, so what's going to happen here is this step function is going to like take a bunch of balls, put them in WebAssembly memory, like run the WebAssembly chamber, which will alter the state of all the balls, and then copy them back. And so we actually then need to copy it back again to like, fuck. We need to copy it. So if we have like, how do I want to draw this? We have like balls here, right? We have like, you know, A, B, C, D, right? And we have like chamber, which chamber each of these balls are in. So we have like 1, 1, 2, 2, right? So for us to like run this function, we need like a contiguous array of these things. Oh, Spiridon, thanks for the raid. What's up, you guys? For those of you who are just coming here, we are working on this collaborative Rube Goldberg machine. It's kind of a shitty demo state right now. But the idea is essentially that each of these like views is defined by some WebAssembly module. And like when a ball comes in and he collides with something, the WebAssembly module is responsible for saying like, I'm going to apply this like physics impulse to the thing because I think that it hit something internally. And then like we kind of are working right now on trying to coordinate between multiple chambers. And the reason that these are like WebAssembly modules is the idea is that we're going to have like this big grid of chambers, and they're going to be defined. They're going to be like uploadable, right? So anybody will be able to make a WebAssembly chamber and upload it, and I will be able to then say, okay, I like this one. I'm going to slot it into like the global simulation here. What we're seeing right now is that the physics for these, all chambers are using the physics of these platforms, but they are being displayed in the correct chamber. So we're making progress. It's just we're not quite there yet. And so that's what I was talking about. Here, we have like we have balls in an array, and we have like which chamber they're associated with in an array as well. And then our chamber is expecting that we have like ball, right? And so we need to like create this array while keeping track of their original indexes. which is doable, super doable. So we'll just kind of say like, this is, let's just, okay. This is fucking stupid, right? The way that this is all oriented is like wrong. But I'm trying to just slowly accumulate to like the correct position piece step by step. And so I'm just kind of doing like what is like the easiest thing at any given step, and then I will refine later. And so the easiest thing at this step is to create two array lists. We'll have chamber balls is going to be an array list of ball. Okay. This needs an allocator associated with them. And at the end of this block, we are going to free these things. So chamber balls dinit. Now we are also going to keep track of the original indices. And this is going to be usize. And we're going to say original indices dinit. So what we're going to do here is we're going to say for each ball, ball, which is like this in this language. We are going to copy the ball and its original index into these two arrays. So we're going to say chamber balls. In terms of technical programming projects, I think this is probably one of the most interesting projects on Twitch. Hey, thanks, man. That's a nice thing to say. I appreciate it. I'm having fun, which is good enough for me. So we're going to append the ball, and then we're going to say that the original indices append the ball index. But we're only going to do this if we match the correct ID. So we're going to say self ball chambers ball ITX is equal to I. This is awful. Gross. Absolutely disgusting. But now we should have everything in the right spot so that we can say here, we're going to say chamber balls items. We run the chamber with these balls, and then all of like after this, the data of these things will be altered, and we can just say for 0 to original index, like this, I guess. This is original indices, and then we're gonna say original IDX I. We are basically gonna copy self balls at original index is equal to chamber balls I. Fuck J. Fuck it, blaze it. We don't know what these words mean. We're not gonna like be able to tie these letters back to like meaningful concepts later, but they're good enough. Then we apply collision between them all. Now this is kind of odd too because the collision is per chamber as well. So yeah, fix. Well, I'm gonna comment this out for a second and bring it back. Because right now, if two balls are in different chambers, if we leave this where it is, then the collisions will happen between chambers. That'll be kind of confusing and weird. So right now we'll just disable ball collision entirely and come back to it. Okay, let's rebuild. And let's see if this is good enough. I mean, it fucking doesn't compile. Of course it doesn't compile, because there's no allocator in the simulation. Interesting. We used to have one, but then we took it away. Allocator. So here we will just kind of stash that like this and say that we want an allocator so that when we step, we have an allocator to work with. Maybe we shouldn't stash it in the simulation. Maybe we should pass it in on step. I don't know. I don't really give a shit. I'll think about that later. Right now, we are in just get something working mode. So just do whatever we got to do. Fuck! So this step function can't return an error right now, so we can't try. But we have to try to push into an array. So I guess we could just catch and return. Fuck it, yeah, let's do that for now. That's easier. So here we'll just catch, return, catch, return, and fix me. Obviously not. Fuck! This guy, no field name items in physics ball. That makes sense. So this is not an array list. Okay. Refresh. Wait. Oh! So when he falls down here, he's not falling here, which is a problem. And we're losing some balls. They're just gone. But we're close. We're close. We're close. We're super close. So this is gonna be an apply wrap. Just whatever the fuck we're doing here is like fucking wrong. So let's think about this. To the ether, yeah, it's just gone. So if ball pause y, oh, this should be less than 0 because 0 is down in this world. The ball chamber is incremented by numballs. I think that's still correct. If ball pause y is greater than 1, we subtract by numballs. Now, that doesn't really fix the fact that this was fucked. Oh, because we're only doing wrapping on X? No, let's see. So this here probably needs like a while. Let me think about this. So say we're at position 0, and we go through the floor. We increment by 2, and we get to position 3. We go through the floor again, we get to position 5. If we're at position 5, we should... This won't trigger, and this will say 5 mod 4 is 1. 0, 1, 2, 3, 4. Oh, sorry. This is 0, 2, 4, which goes back to 0. So that seems fine to me. Now, what happens if we go out the left side? So here we go at the left side, and we get to negative 1. We add 4 to negative 1 to give us 3, and then nothing should... Oh! This is wrong. This is wrong. Long stream today? Okay, yeah, so we've started doing this, like, pre-stream, I'm calling it, where we still have, like, the 2-hour focused work of, like, a task that we're working on, whatever. But before stream, like, I've been doing a lot of stuff off stream, where I'm spending, like, maybe, like, 4 hours in a day. Maybe a little less. Like, maybe a little more, maybe a little less. It depends on the day. Probably less. Probably more, like, maybe, like, 2 or 3 hours on just, like, cleaning up and small fixes. And so I'm like, we might as well stream that too. So we're calling it the pre-stream. We like listen to music. We do like small tasks that don't really fit like a narrative that a YouTube video would need, i.e. like a Twitch, like a VOD that I need to like title and thumbnail. And then if people want to see archives of those, I'm putting them on Patreon. But I don't really, yeah, we'll see. Okay. So this is wrong. When we go to the left, we don't want to just subtract the chamber. We want to check if ball chamber mod num chambers per row is equal to 0. Ball chamber plus is equal to chambers per row minus 1, like this. Yeah, plus equals chambers per row minus 1. Otherwise, we subtract it. Okay. So this doesn't like this for whatever reason. What the fuck does it not like here? Oh, because this is to be, Okay, we'll do X first. That will make this kind of all line up. We can say that we guarantee that this is above 0 up here. And so here we can just say mod like this. Like this. Easy peasy. Let's try refreshing again. I don't understand why these guys are wrapping down into themselves. Here, like, they're going out to the left side correctly now, and how did we end up here ever? Like, these guys, how the fuck did these show up anywhere at all? What the fuck? I mean, clearly our like Y handling here is wrong. Um, let's think here. Going through floor. Let's just see if we can like get any semblance of what's going on. Okay. So it is going through the floor, and then whatever we're doing here is just wrong. This is so fucking stupid. This should be chambers per row. I'm just fucking. There we go. Whoa. How do we end up here though? Okay, so I don't like this. Let's maybe rm-rdb build run, and can we maybe upload? Just we will upload the Plinko chamber like 4 times. So if I go back 2, 3, 4, and then restart this thing, hopefully our simulation shows. Fuck, man. Okay. That's annoying. That's annoying. So we can't upload chambers at all now, which is super fucking cool. Super cool. Okay. Let's see. Let's try to like at least try to like deduce what's wrong with chamber upload, I guess, because we need this. Not logged in. Yeah, you know what? That would do it, huh? So maybe it's just not broken and I'm just an idiot. Okay, so that looks like it worked. So let's make 2, 3, 4. And then restart the server because they only apply. Okay, here we go. So this guy comes down here and he's coming out here now. So there's an off by 1 error somewhere here. Looks like coming down here, it's working okay. Kind of going over this left edge here is working. Where did this guy go? When he went off to the right here, he should come back over here. So there's, here we have to check if ball, we need to do like the same kind of thing here. Is equal ball chamber plus 1 mod chambers per row is 0. We say ball chamber minus equal chambers per row. Minus 1? Yeah. Else we increment by 1. Okay. Why are they changing colors? It's just a bug. It's just a bug. Fine, we'll fix it so that people will stop asking. But it's because like the color of the ball is determined by the index in the chamber that it's in. And before that was constant, but now it's not. So here we just need to take this wherever the fuck it is. Oh, I don't remember. Simulation renderer probably. So here we'll just make it red unconditionally, and then that question goes away. Then it goes away. Okay, and then it's just when they fall off the bottom here. I think they're going to the wrong one up top. Yeah, it's going to the wrong chamber at the top. So that's here. Ball pause y less than 0. We increment by chambers per row. So here we're at 0, 1, 2, 3, and we increment by 2. So we should should end up at 4, 5. Then we do 5 mod 4. What am I missing? What am I missing? So this guy, 0, 1, 2, 3. We go off the bottom, so y is less than 0, and we should be at 4, 5. Then we do mod 4. 5 mod 4 is 1. So what the fuck is the problem? And this works when it's 0, 1, 2, 3. Oh, because there's no mod here? Okay, here's what we're gonna do. We're gonna set num balls to 1 so that this is easy to track. Then we're gonna go here and we're gonna say std debug print chamber ball chamber. And then chamber after mod. Let's just see what happens there. So here is at 0. What the fuck? And here we only want to do this, I guess, if it changed. So we'll say const before, seal ball, chamber, const after, I guess we'll just say here, if ball chamber is not equal to before, this is before. The fuck? So you're running chamber after mod 0? Oh, I'm an idiot. No, this is ball chambers len. Oh, ball chambers len is the fucking number of balls in the scene, not the fucking number of chambers. God damn it, this is chambers len. Which I think is what the guy in chat was trying to say, and I just didn't quite understand him. Chambers len like this. Really? Why is this? So this should also be chambers len here. And we'll just like, I guess, int cast these. Should be fine. Should be fine. He doesn't know the type, so we'll say as i64 here. Okay. There we go. Okay, and then it comes with the right here. I'm not sure if here he went off the right side here, which is why he wrapped all the way around. Yeah, it does look like this is working. It does look like it's working. It sucks that they get stuck in this state, but we can fix that once we apply physics to the ball. Like once the balls can collide with each other, that should fix itself. So let's go back and apply ball collision. So here, I guess it kind of makes sense to just apply ball collision within a chamber. Because we're just gonna kind of ignore for a minute the fact that balls will like wrap over the edges of one chamber into the next. We'll just pretend for now that they're only ever in one chamber. That just makes our lives easier for now. And I guess we'll do this. And that actually might just be good enough. This should not be self balls, it should be chamber balls. Here and here. That might be good enough. Might be. Fuck! This is chamber balls items in both these because it's a dynamic array. Fine. Fine. If that's what you need. And let's add more than one ball again. So non-balls. This is kind of like up this to like 20. He doesn't like that. Unreachable code. Assert that the ball pause y is less than or equal to 2. That's crazy. That's crazy. But I guess we can just adjust that these like if statements to be while statements. And we can just say that ball pause x minus equals 1.0. All right. Sure. Then we don't have to do this down here. Let's try that. Here we are. Oh, we can take those asserts out now. I get it. We don't need them. We don't need them. Okay. I think that this is working, but it's really fucking hard to tell. Like, really hard to tell. But I do see, like, the things that get stuck in the middle, they do occasionally get knocked out, which is good. And I do believe that this is correct. We could maybe I don't know. This feels okay. This feels okay. It would be nice to fix this, like, we need to use balls that are within one radius of us, which is kind of odd. So, like, we kind of need some sort of, like, spatial awareness of like where chambers are relative to each other, which we kind of have, right? I guess you know that you need to look at the chamber one index higher than you, wrapping per row, one index lower of you, above and below. And then you just basically say, like, if the ball's radius, if the position plus the radius makes it into, like, my bottom edge or something. Oh, it's such a pain in the ass. Such a pain in the ass. Do I want to keep going? It's doable. It's doable. Okay, let's try to render the ball. Let's start by rendering the ball in both chambers. And then applying physics in both chambers. I think that makes more sense. So let's first of all get rid of these fucking prints. Fuck these prints. Let's go into our rendering code, which I guess is in simulation renderer JS. But we actually don't want this. We actually kind of want fuck. What's it called? Index.js, I guess, is where this is happening. So here we kind of select the balls that are within our current chamber. And I guess we want to, instead of doing this, we want to look at the things that are adjacent to us. So let's just start with horizontal. We'll do vertical in a second. That makes my life easier. So I guess we kind of need to know, like, the row layout here for us to do this effectively. And it's kind of weird to me that, like, the client would be doing this logic at all. Does it make sense for the server to tell us which balls are in which chamber? then we can just kind of like, we can just say chamber balls. That doesn't seem crazy to me. It doesn't seem crazy. And then we can reuse the same code once we want to get into physics. Let's do that. Let's do that. So let's change this so that when we ask for balls, instead we'll kind of just group them by chamber. And we're going to have some sort of duplicates in there, but that's okay. It's not the end of the world. So do you have the build on save ZLS set up? I don't know. I think I might have turned it off. I did turn it off because it was causing slowdowns. Can you have 5 columns in browser client 1 and only 3 columns in browser client 2? That would not be, I think, good. I think that we want the simulation to be like fixed everywhere. So I think that it being like fixed to the same width in all clients makes sense. Okay, so we're gonna have chamber balls, and I guess we're gonna do like the same thing here. What is handling your HTTP request? Is it curl? We have a hand-rolled-ish HTTP event loop server thing. So we wrote this like event loop that basically uses epoll to like tell us when file descriptors are ready to be read, and then we have this like HTTP, like for example, reader that basically like yoinks out as much. He like says like, am I reading the header? Am I reading the body? If I'm reading the header, I'm going to try to like consume as much from the TCP socket as possible. Once I think that like I'm finished, then I will like try to parse this thing with some like Zig standard library stuff. You know, stuff like that. And then we do have like an HTTP client that's using curl for authentication stuff from Twitch. But most of the server stuff is just like our own hand-rolled shit. Is WASM syntax the same as assemblies? It's pretty different. It's pretty high level. So the WASM model is a like kind of stack machine, I think they call it. Let's see if we have like an example here. Right, so they do things like in order to like add 2 numbers, you put 2 things on the stack. So here they're gonna get like some local in register value 8 and then the number 1, and then they're gonna add that together. So this is gonna have like this value plus 1. We did a video where we were like raw dogging WASM for a little bit, and if you want to check that out, that's available somewhere. Hold on, it's kind of fun. I had a lot of fun when we did that one. So it's at the top. This guy, if you want to see what the fuck is going on in a WASM module, this is how he was struggling to figure it out. Oh, Christoph, you're saying that I can get the build on save to go like really fast if I do no emit bin. I think that the slowdown I think is also caused from like my build scripts having like some complex stitching together, right? So like my Zig build is going to run how do I call this? Like a Rust build as like part of my Zig build and stuff. So there's like a lot of extra complexity there. So I just turn it off. I mean, I don't mind. I don't really mind just running the compiler. It's manually. It's not the end of the world. Not the end of the world. Never mind. Keep it turned off. Yeah, exactly. Okay. So I guess at some point we kind of did this assign balls to chamber IDs and call balls in correct chambers. We just didn't write this down the times. And I guess now we're kind of on this. When balls in multiple chambers, step in both. And so what did we say we're going to do? I guess we kind of started this before now. We had made some sort of progress on this. And it was that in our server code, we wanted to return balls per chamber. So we were calling it chamber balls in here. And I guess the first implementation of this is just gonna look kind of like, ooh, this is ugly. This is really nasty. Super nasty. Fuck. So we have like in our simulation, ball, And then we have like chamber IDs here, right? So like these three guys are in chamber 1, or sorry, like indexes 0, 1, or 0, 2, and 3 are in chamber 1. Index 1 is in chamber 2. And so if we want to do like this, like contiguous memory of balls by chamber, you have to do like find adjacent chambers, push balls into new array, then like extract push arrays into array, which is just kind of, it's kind of nasty. Okay, I need to think about this a little bit. I think I need to think about like where, like how I'm gonna handle this like split logic. I don't know where I want it to live, and my head hurts. I'm getting kind of tired. So, yeah, I think I'm gonna call it for today there. I know we're only an hour and a half in, but I think we made pretty good progress. I'm pretty happy with like the way it's, fuck. Hold on, let's show it at least. Fuck! I changed a bunch of, undo. We have to undo back to the point where it was good here. Yeah, I'm pretty happy with this where, fuck! Up two directories? I'll be happy in a second. I'm pretty happy with, no? Oh my god, what did I do? What have I done? Oh my god. If only I had git committed. If only. I think that was the one. Oh, I think that was it. We should build and run here. Why do I do this to myself? Okay. Still no? Really? Fuck. Oh, that's really bad. Okay, I'm not gonna call it here until we're back into a working state because this is really fucked up. But I'm just gonna fix this and then we'll be done and then we'll call it. So this is in simulation state. What the fuck am I? Hello? Where am I? Simulation state here. So this guy's supposed to return balls, which he does. Is this when we network response, we do have balls with no chamber states. Oh, but they don't have their chamber attached to them. Right. This is supposed to be balls and ball chambers like this. Woo! Scary. Scary. Undo redo buffers, spooky. So what's it mad about? Chamber balls, no field name chamber balls. Ah. Okay. Please let me get back. Please. I want to get back. I want to get back to where it was working. Okay. No? This is really bad. Response, this has balls, ball chambers, chamber states. Okay, and then our index.js, ball chambers, chamber, here we go. Please? There we go. Okay, I'm happy with this. Where we have balls are correctly going between chambers vertically and horizontally. We just need to be able to like lay out chambers a little bit more advanced, maybe like swap them out for different ones, but this is pretty good progress for today. My head is tired though, so I want to call it. So apologies guys, but that's it for today. Thanks for watching. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time. We're working on this Rube Goldberg machine now, but if you are new here, there is a bunch of other stuff in the past on YouTube organized into playlists. Stuff you might want to check out: operating system, like neural network, terminal emulator, QR decoder, video editor, lots of fun stuff back there. I guess I should say we do the main stream at 2 to 4 o'clock Pacific. We've started doing this like pre-stream thing where, if you were to leave the code in the state where I left it just now, we would never get anywhere because we wouldn't be able to, the code base would become such a pile of crap that it would be impossible to work with. So we've been doing this like pre-stream thing where like maybe around like 12:30 or 1 Pacific, we might work on like some like cleanup, small tasks that need to get done, like just kind of like things that I would normally do off stream. So if you want to check that out, you can catch it live at around like 12:30 Pacific onwards, or on Patreon they get archived. Anything else I need to plug? Like, subscribe, Twitch Prime, all that good stuff. And yeah, let's go out there. Bye YouTube, Twitch. Let's find someone to raid.